So section 3.2, solving systems of two linear equations by substitution and elimination. So we did by graphing before. This way is just a little bit nicer to use. You don't have to worry about the human error that comes with graphing lines. So first, by substitution. This means we need to get one of the variables by itself and then substitute that into the other equation. So in this case, this x is easy to get by itself. We could subtract the 3y from both sides. And now notice x is by himself. We can now substitute this whole value in for the x in the other equation, because this is equal to our x. So now we would have 2, and instead of x, this whole expression, and then minus y equals negative 10. Notice now we only have one variable in our equation. Our one variable is y, so we can actually solve to get that y by itself. So now notice we have our y value. We can now use this and plug it into our expression here and figure out what our x is. And remember, we found out our y was 4, so we just substitute in 4 for our y. So our answer is negative 3, 4. But what we still need to do is check it to make sure that this is correct. And so to check it, we still need to plug this into both equations and make sure it works. So using our first equation, so it works in the first equation. Trying the second equation, it also works since it checks in both. This is our answer. Helpful hint though, if it does not check, if it doesn't work when you check it, this means that you made a mistake somewhere. So if it doesn't check, that means you need to be going back through your work and figuring out where you went wrong. So, same idea, solving by substitution. Notice there isn't an easy variable to get by itself right now, so we can just pick one. I'm going to just go with this equation and get our y by itself. So, we'll have 1/2 y equals 1 minus 2/3 x. And now we don't want that half, so we can multiply everything by 2. Now notice we have y by itself, so we can use that and substitute that value into the other expression and for this y here. Make sure when you're doing substitution, since we solved for this equation first, we then substitute it into the other equation. And it might help to change this 2 1/3 into an improper fraction, which would be 7/3 x. And then we can divide by 7/3, which is the same as multiplying by 3/7. Notice our 3's and our 7's will cancel out. So we'll get x equals 3. And then we can substitute that back in to figure out our y. So our answer should be 3, negative 2. But remember, we have to check to make sure. So it works in the first one. Checking in our second equation. Notice a negative times a negative is a positive. 1 plus 3 is 4. So here's our answer. Last one by substitution. And notice we could get this y by itself, or in this equation we could just divide by the 9 and get the x by itself. It doesn't matter. I'm just going to go ahead with this first one and divide everything by 9. And if we have 12 over 9, we can divide them both by 3 and get 4/3. And then just substitute this into the second equation. And notice we're left with 4 equals 4. And this is a true statement. So what this means is this was a dependent system. Remember how in last section, if two lines were the exact same line or had the exact same equation, they were dependent? Same thing here. One thing to keep in mind though, if we had gotten a false statement, this would tell you that there's no solution. The lines don't intersect. So now we're going to move on and do this by elimination. And most people tend to like elimination better. And all this entails is you want to add the equations together. The key thing being you need to have one of your coefficients so that when they add together you'll get 0. So notice in our case we have a positive 3y and a negative 3y. When we add these two equations together, we'll have 7x, 0y's here, and negative 7 plus 7 is also 0. Solving this for x, we'll get our x is 0. And now that we have our x value, we find our y the same way we did before by just substituting this into one of our two equations. So there's our answer. However, we still need to check. So it works in the first one. Trying into the second one. So it works. So here's our answer. Now notice our x coefficients are at least similar. They both have a 2, but we need them to be opposite of each other. So how we can take care of that is just multiply one of the equations by negative 1. So then our first equation is still going to stay the same. Our second equation, multiplying that negative 1 by everything. Now notice the x's have those opposite coefficients. So now when we add our two equations, those will go to 0. 1y plus 5y is 6y. 7 plus negative 3 is 4. When we divide both sides by 6, we can simplify and get 2/3. And then we'll go ahead and substitute this into one of the equations. Once again, it doesn't matter. I'm going to go with the first one. So we'll get our answer. But once again, let's check it before we circle. And 9 divided by 3 is 3. So it checks. So here's our answer. Now notice, none of our coefficients are the same. And so what we need to do is multiply one of the equations by a number, or both of the equations by a number, to get our coefficients to be the same number, one positive, one negative. So notice we could multiply the second equation by 2, and then we'll get our y's to match up. So our first equation will stay. Our second equation becomes 4x minus 2y equals negative 14. So remember that 2 gets distributed to everything. Now notice our y's are opposite, so we can add them. And we'll get x equals negative 2. Now we have to figure out our y. But once again, we've got to check our answer. It works, so that is our answer. Alright, once again, solve by elimination. We have fractions, but think back to chapter 1. We can eliminate our fractions. And we can do this by multiplying by what would be our common denominator. So in this case, our common denominator would be 6. And actually in this case, it would be 6 as well. And so now, our equations would be so now at least these look a little easier. We don't have our fractions. However, we still don't have any coefficients that match up. So what we need to do is multiply both equations by a number to get our coefficients to even out. And it doesn't matter whether you want to work with the x's or the y's. I'm going to go ahead and work with the x's. And notice we can get our x's to 24. So let's multiply this by 3, and this one by negative 8. And we'll get 24x plus 9y. So we'll have our two equations. Now notice our x's here are opposites, so we can go ahead and just add our equations. So our x's go away. So we'll get y is 2. And we still have to get our x. And so I'm going to go ahead and plug this in for y. Remember, though, we do need to check our work. So there's our answer. Alright, now, once again, we're going to solve the system with elimination or substitution. Notice it doesn't tell us which way to use it. Notice, though, we already have variables by themselves, so substitution is going to be your best bet. And it doesn't matter which one you substitute into the other. So I'm going to go ahead and just substitute this one in for the y in the first equation. We'll get 0 equals negative 15 halves. Well, 0 doesn't equal negative 15 halves. So what this tells us is there is no solution. So this means the lines don't intersect anywhere. Keep in mind, once again, though, if we'd gotten a true statement, such as, 7 equals 7, then this would be dependent, or infinitely many solutions. And that is all for section 3-2.